Hey everyone. I wanted to just these are going to be some quick video instructions about how to find a curve to define your shape, right? So we're doing this project where we want to find the center of mass of a shape, and we're gonna use Desmos to do that. So we're gonna in this case use two curves for the top and the bottom of our shape. We're gonna find functions. We're gonna use polynomials. Um, and I just wanted us to get a little experience using some new technology and thinking about how they work. Desmos is great. It's really easy. It's really user friendly. You don't need to know a whole lot to get things to work. I'm not a programmer, and I have a pretty easy time figuring out how to make it work. And it's got some good help to do these things. So I can show you a couple of the processes here. There are certainly more sophisticated ways to do what we're doing, but we're not going down that road. And there's probably even better ways to do it in Desmos. I'm certainly not an expert in Desmos. In fact, I'm going to show you a long way to do something because I think it can help you with some other things if you get interested in this. And then I will show you a shortcut as well. But you might find some shortcuts for the things that I do. I'm happy to hear about those. But this is what I've got right now to get our job done. So we're going to take this shape that I've linked for you guys in the project and bring it into Desmos. And it's just a drag and drop. Desmos can take your file that you hopefully have on your desktop, and it just drops it at the center of some coordinates. And if you click on it, you get a few things, right? You can scale it as you'd like. You can come up here and change the angle in radians, right? So I'm just rotating it, but I'm gonna keep it as it was. I think that's probably about right how I'd want it. I'm trying to look at it and imagine, can I turn this into a top and bottom function? And as it's oriented right now, I can pretty clearly see in my head two curves so that each of them are a function, right? They don't double back on each other where they fail the vertical line test, so they are indeed functions. You can also do some things like change the opacity if you want to be able to see through this thing a little bit. That's actually kind of nice. But that you can do whatever works for you. You can leave it where it lands when you place it, but I'm for no good reason. I'm going to place it approximately at the origin. I'm not going to worry about being perfect, and just keep it in the first quadrant. I don't know. That just feels like a nice thing to do. I'm not sure why. And then I'm just going to find a zoom I like. I want to be able to see the whole thing at once and not much else. Seems a little big. I wish I had a tighter control over the zoom, but it does seem to scroll a bit fast. I can probably change a setting, but I'm not going to worry about. Whoa. All right, that's good. No more zooming. All right, so there's our shape. So what we're going to do is we're going to get. I'm gonna lay some points. I'm gonna look at just the bottom half of this curve. I'm gonna lay some points out and then tell Desmos to find a nice polynomial that goes through those points. So I need to add a table. I like the picture to be in the top slot there. So what the table gives me is two variables, an input variable x1 and an output variable y2. And we can put in some points. I could try to put points along the bottom of this curve and eyeball what the coordinates would be and adjust them by typing, and that's reasonable. But it turns out they have a nice feature here that I'll show you. I'm going to just put out a stack of points. I'll show you what I mean. I'm putting in coordinates. I'm putting in all x coordinates right now. I have that's a good number. We'll start there, and then some y coordinates. And notice as I complete the coordinates, we now see a point at 4, 1. And there's actually 6 points sitting there. Desmos is thinking of them as these individual objects in a stack right now. And if I'm going to click and hold on this little circle next to Y1, and I get this little menu. And the feature I'm most interested in right now is this drag option that lets me grab points and move them. If you click these other ones, this means you can only drag them horizontally. So if you wanted to keep your y values fixed but change the x values, or fix the x values and change the y values. But here we can just grab them and move them around as we please. if you care, you can also change things like the shape they're in, if you like little X's or little squares or little stars or whatever you want to do. Let's do little stars. You can get little outlines. Oh, that looks nice. We'll do that. I'm not actually sure what the lines thing does. I think it'll make lines connecting them, but we'll play with that later. Let's do one thing at a time. So in any event, the important one is turning on the drag feature. And so what I can do now is as I click on, I'm clicking on the top point, I can move it out approximately where I think, just to some point on the curve. And I'm just going to distribute these points. I think the stars are actually making this harder, so I'm going to switch to a more reasonable shape. Let's go back to open circles. And I just turned down the opacity too, so I can see the shape under them. And that seems actually like a good thing to do. All right, so I'm just throwing these curves, these points out along the bottom of the curve. And also note, when I stacked my points, the one on top was the last one I put in. So I chose to put that furthest to the right. That just kept my table in order. So the first coordinate we get is the one that's furthest to the left, closest to the origin, and they move to the right. And that might be helpful later when we might end up deciding we have too many points or adding a point. Whatever we want to do is fine. But I don't know. To me, it feels nice to have them in an order. All right. Now, here's the long way to do something. I'm going to find a polynomial function. Well, let's do a quick example with just a line. Let's pretend we want to use a line here, but we can look at this thing. It's very clearly not a line. But I just want to show you the process first with a very simple idea. What I'm going to define is a relationship between x1 and y1. When we talk about relationships between variables, we're talking about equations, right? So we'd have y1 equals some function of x1. However, we're going to use, instead of an equal sign, we're going to use a tilde. This is telling Desmos we want it to do a job. And the job we want to do is when we write our relationship, there are going to be some constants, right? If we wrote the equation of a line, we'd have y is equal to a constant times x plus another constant. And we're telling Desmos to find those constants for us. So let's write that. I'm going to put some constants in here. So if I think this should be approximated by a line, I need a constant plus x1 times a constant. All right, so look at that little equation. Y1, I'm just going to say equal for the tilde because it's really playing the role of an equal sign, but it's giving Desmos some commands too. Y1 equals the constant a0 plus the constant a1 times x1. What Desmos does is find a line that best fits these points, right? There's no line that goes through all these points because they're clearly not in a line, but it finds the best line and tells us what constants to use for this best line, right? It tells me what a0 is and what a1 is. And so if I was trying to approximate this curve with a line, I now have my line. It would be y equals 1.73 plus 0.16 times x, right? Side note, best line is a somewhat subjective term, though there are some standards. My guess is that Desmos is using something called the least squares method for finding a line, where you essentially just look at the error between each point in the line. The distance, the vertical distance between each point and the line is your error for that point. You square the errors and add them up, and you find the line so that sum is the minimum. I believe that's what they're doing, but I'm not sure about that. There's lots of methods out there. So this is a nice general thing. If we for instance thought, maybe I think actually I want an exponential, I can do an exponential too. Like I can call this, let's just call it b x sub 1, sorry, ab to the x sub 1. right? So now that red curve is an exponential. I'm not going to zoom out because, but you can see it's got a little bit of a curve to it because I'll never find the right zoom again. And it's telling me what the constants A and B should be to make that exponential, right? Again, I don't think this looks anything like an exponential, but Desmos will still do the best it can to find an exponential that best goes through those points. All right, so what we're going to use to approximate this curve is going to be a polynomial. We've got the beginning of a polynomial here. It is a polynomial. It's a linear polynomial. Let's turn this into a quadratic by just adding some more terms. Right? So we can see with the quadratic, we're already matching a lot better. You can name your constants any way you want. I like to have the one constant with subscripts, and the subscripts match the powers on x. This is a pretty standard way to write polynomials, so it's my habit. You don't have to do that, but I don't know, it feels right. And you can see, as we added a constant, Desmos is giving us the values for the constants to make this curve best match. Right. Let's add a couple more terms. Let's go to a cubic term. Whoops. That's getting to be a pretty good match, right? And remember, I don't care what happens away from here, because when we do this, we're just going to use the piece of the function, over this interval that the shape covers. So I don't really care what it does outside. I'm just looking between the two endpoints of my interval. Let's add a quadric term. Let's add a degree 4 term. That's a pretty good match. I'm going to add a couple more and just see what happens. At some point, it won't match. There's not much happening. Let's go with one more. 6. That's pretty close right there. So that's a pretty, I think I'm going to call that good. You can decide how much it matters, right? There's this little bit here. The other thing we can do is you can grab points after you've created this regression. This is the regression is the matching thing, right? And as I move the points, it starts to adjust its function. It's changing those constants, right? So you're not gonna you're very unlikely. I don't think we're gonna get a perfect match. We're not gonna get a perfect match, but right, to me that's a pretty good fit right there. Okay. Again, this is this regressions are usually used where you have data where you're not changing it and you're trying to find a curve to fit the data. We have the benefit of we're not really after some specific data. I just want to match the shape, and so with that little bit of changing the curve, to me that looks a little better. It's cutting off a little of the shape and adding a little elsewhere. I wish I could get this to curve a little more, but I'm not going to worry too much about it. And that's it. There you have your this would be the curve. So now the function you have would be f of x, if I'm going to call the bottom function f of x equals, and we have these constants down here, right? And you can copy them. A quick, you might do something like this. 1 second, sorry. X equals, now we have to change, I need to delete all the subscripts. Oh, I guess it won't let me do it. It's going into, oh, there we go. It's easy. So all I'm doing now is defining the same function without with that as the general. Oops. There we go. All right. So now all I've done is taken away the subscripts, because now this is a function. It doesn't care about the points. It's just I'm just basically copying the a0, a1, a2, a3 constants to write that function. And so now as you're working with these functions, you might use Desmos to do some of your work. There's some computations you'll have to do, things like that. You've now got it sitting there for you if you need to compute its value at some point. I'm going to leave that up to you. You guys have some work to do with these, but that's a good way to get it in your into Desmos in a quick way. So that's it, right? You're going to repeat this process on the top curve. You'll make a new table, new set of points, a new function. and you can picture something that's going to go just right over the top, intersecting as close as you can get to these endpoints, so that you're getting a pretty good approximation to this shape. And then you'll use the methods of the text to take that shape, the region defined by your two functions, um, to determine the center of mass. Okay. I'll also point out you can create. I'm logged in. You can create a free account with Desmos if you haven't already. I would highly recommend it. You can save things and come back to them. And so if there's things that I've done and you want to copy into your account, you can. As you get more experience with it, it is a pretty good learning tool. You can play a lot with it, and so you'd want to periodically save your work just in case, right? I don't have to type in all these things. We did a little finessing, and so whatever. Let's call it 152 center of mass. Just type it out. I've learned to type things out fully because it just takes a second, and then when you're searching for it later. Spring 2025. It's easy to find. Because if you do create an account, as long as we're looking at this, you can, right? You can see on this left-hand column, these are all different things I've created. Most of these are mine. I don't know where it stops being mine. Oh, I think the top is mine, and these are other people. So you can see that I have all these up here, plus 682 more, which I probably need to go in and cull some of those because I don't think they're all useful. Some of them are probably from the first couple of weeks I try to. Ooh, that's a new button, attempt recovery. So I guess save often, but maybe they've got a new feature that lets you grab some of the stuff you might have forgotten to save if something happens. Okay, in any event, and you will need to save. Sorry, you will need to save it and in an account because when you're done, part of the project will be sharing this link so I can look at your work and see what you did. Because I do want to, it's not that Desmos is the most important thing, but it is a good skill to get used to learning some new technology. So I think this is a pretty low, there's not a whole lot here, but you'll get some good experience with this. And so you can come up here to this share button, this little square with an arrow in it. You'll copy the link they give you, and that link will be part of your submission for this. So, all right, that is it. Please ask me any questions if something comes up. Otherwise, good luck.